Center of mass is the distribution of mass around a hypothetical point, otherwise known as the balance point, where mass balances and where the entire mass can be assumed concentrated. Let's look at the first part of this definition. It's the distribution of mass around a hypothetical point where mass balances. A good example to look at is a seesaw. Here we have a seesaw where mass distribution on the left-hand side is equal to the mass distribution on the right-hand side. Notice it doesn't say the mass is equal, it's saying the distribution of mass is equal. Here is your pivot point in the center. That is your center of mass. And the center of mass says distribution of mass around a hypothetical point where mass balances. So here we have a balance of our distribution of our mass. If we did not have a balance of our distribution of mass, our seesaw would be tilted where one side would be lower than the other side. But because our seesaw is exactly horizontal or parallel to the ground, our distribution of mass on the left-hand side is equal to the distribution of mass on the right-hand side. If you've ever sat on a seesaw with two people on one side and you're on the other side, you need to move your mass forward or back on the seesaw to get the seesaw to exactly balance. And that's what we mean by a distribution of mass. The mass is located at a certain distance away from the pivot point, and when the masses are exactly in the right spots, we have this exactly level seesaw. And we call this level in our center of mass. Let's take a look at the second part of our definition of center mass. It's where the entire mass can be assumed concentrated. So here we're looking at the solar system. We're looking at all of the planets orbiting in the counterclockwise direction, and you would think the center of mass of the solar system, where the entire solar system could be balanced on one single point, would be located in the center of the sun. However, it is not located in the exact center of the sun. It's located at about 75% of the way out from the sun. So the center of mass is located not at the center of the sun, but still inside the sun, but about 75% of the radius outside. So everything orbits around the center of mass, including the sun. The sun makes this little wobble in the sky every year that the Earth goes around the sun in one orbit. Now this definition, the second part, says where the entire mass can be assumed concentrated. So we can take the entire mass of the solar system and put it at this one particular point. So let's do that. Let's take the entire mass of the solar system and make it one point and move it into the motion of the Milky Way galaxy inside our local group. So the white circle here in the center is the motion of the Milky Way galaxy, and we can put on this circle a blue dot indicating the motion of the solar system. Remember, we replaced this entire solar system by one dot. That dot is the center of mass, and it's the point where we can take the entire solar system and put it at that one particular mass and look at its motion inside of a larger object. So its motion inside of a larger object could be represented by its motion inside the Milky Way galaxy, which is indicated by the Milky Way galaxy's circle around the center of an even larger object, which is the local group. And all of these objects are moving around the center of mass of the local group as well. So this is what we mean by center of mass. It's the distribution of mass around a hypothetical point where mass balances, and it's where the entire mass can be assumed to be concentrated when we're looking at motions in larger objects.